Hello everybody. We will continue our classes on physics by distance learning. So this presentation is for grade 11. We still at block 4, electricity and magnetism. So please open your book on page 228. Our presentation today will consist of three main parts. First part is the magnetic fields. What is a magnetic field? And then electromagnetism. What's the difference between magnetic and electromagnetic? There are a big difference here. And then we will go through summary on both of those topics. So please open your book on page 228. I think the number of page here is wrong. Please open your book on page 228. 228. Magnetic fields. Magnetic fields. So we can say here any magnetic can affect any bias of magnetic material that is nearby. So if we put some material here near to this magnet, so this magnet will affect all of these materials here by two type of forces. The force maybe attract the material here or maybe repel the material, some material is there. So we have two forces, attraction and repulsion. So we see that there is a magnetic field around the magnet. Any magnet, there is an magnetic field here, as we can see here in this figure. So this is the magnet with S N balls. So this is S ball and this the N balls. There are a magnetic field, as we can see here. The strongest place of this magnet is concentrate here at the two poles, and it will be less here in those sides. So very strong magnetic field is here and here at the poles, and less here. You have probably done some experiment with iron filings or small compass to show up the magnetic field of a magnet. So we'll watch some videos on magnetic field showing how we can illustrate the electrical or magnetic fields of a magnet. So we'll go to watch this video. So what we have here, this is a magnetic with NS balls, and then we will put like cover sheet of small bubbles or some plastic here. It's a cover of plastic, and then we will put some iron filings on this one, and we will see what happens here. So if you put a compass here or here, you will see the direction is where it's the NS poles. So this is the magnetic field. This is the two poles here, and the direction of the field is in this direction, here, or this side here. Comes from N to S. All lines, it comes from N to the S poles. Okay, now, so in this figure here, 16.7 shows how we present the magnetic field of a single bar magnet using magnetic field lines. Those are magnetic field lines. Of course, the field fills all the spaces around the magnet, but we can only draw a selection of lines to represent it, to represent just some of them. So now what we have here is the pattern, the last pattern, or we will take this one with more, we will represent some lines here, like in this figure A. So what we have here, this is a magnet, this is the poles, SN poles. So the lines of the field, it comes from N to S, from N to the S, N to the S. So we just put some lines for explanation. So the pattern tell us two things, two important things about the field. First one is direction. Direction. If you were to place a tiny compass at a point in the field here, as we say in the last video, it would align itself along the field line at that point. So we use a convention that says that the field lines come out from north poles and go to south poles. So all lines, it comes from this, come out from N into south poles, from N pole to south pole. The second thing is singlet. Line is close together here indicates strong field. So the line is close to each other, that means it's very strong field here. And the line is here, it's not close to each other, so the field here is less than here, as we said in this figure. So the field is very strong here, and is less here. Okay, now we can also show the field pattern of two magnets attracting here. They are attracting each other and revealing here. So figure B is showing two magnets with different poles near to each other, NS poles or SN poles near to each other. So there are a strong force here, and this figure C is showing same poles in N or SS. So there is a force here, strong force here. The force here is called or known as attraction force. This is an attraction force, and this one is repulsion force. This is a repulsion force. So there is a magnetic field here, and there is no magnetic field in this point between the same poles, and there is a magnetic field between different poles. So as a conclusion here, we can say that a magnetic material is only one way of making a magnet. So there's an alternative method is to use an electromagnetic. So in this topic we will discuss what does it mean by electromagnetism. So magnetic material is only one way of making what? Magnet. There is another ways or alternative methods. is to use electromagnetic. So electromagnetic is made, this the best one of electromagnetic is made from a coil of copper wire. This one is a coil of copper wire. It's twisted in this way. It's twisted like a ring one. So a coil like this, so the current will move from this part here. We will pass some flow of currents here, and then we will receive it here. So the current in is from this side and current out from this side. So when current flows through the wire in this direction, so there is a magnetic field around the coil. There's a magnetic field around the coil. It's like this one. So the direction is the same. It's from N to S, and comes out from this one, come to this one. So it comes from N to the S poles. Okay. So there are three ways to increase strength of an electromagnetic. There are three ways. First one is to increase the current flowing through it. So if we need to increase the electromagnet, so we need to increase the current flowing through it. So the greater the current, the greater the strength of field. This first one, or first method. The second method, by increasing what? The number of turns of wire on the coil. The third one is by adding or adds a soft iron core. So these three ways to increase what? The strength of an electromagnetic. So electromagnets have the great advantage that they can be switched. So what's the advantage over electromagnetic over magnet or normal magnetic? It can be switched on and off. So this is a very, very important thing. It can be switched on and off. Simply switch off the current and the field around the coil disappears. So if we need to remove the electrical field, just we turn the current off, and then we return it by turning the switch on. And this is a base or a base of, or the basic of a number of applications of the electromagnetic. So one example of using electromagnetic, or the advantage of turn on and off electromagnetic, is scrap yard. So electromagnetic that move large piece of metal and build off scrap around in scrap yard, as we say in figure 10. So we can say some video simulation of scrap yard, and then we will return back. So this is an electromagnetic here. This is the magnet. There is an electricity comes from this wire here. So when the current is on, the magnetic is working, say. And now the current is off. Current off. Current on. Current on means magnetic field. Current off, magnetic off. Okay, so the topic of magnetism, we already cover and investigating or this magnetism, investigating permanent magnets and magnetic materials. The core number 2 is describing methods for magnetization and demagnetization. Number 3, explaining magnetic forces in terms of magnetic field. And number 4, describing electromagnetics and their uses, as we said in the last video. So what's the summary of the topic magnetism? A summary is, number 1, we have like poles repel each other and opposite poles attract each other. So the same one repel each other and the different ones, NS for example or SN, poles attract each other. So there are two types of forces, repulsion and attraction, depends on the poles. Summary number 2, soft magnetic materials are easily magnetized and demagnetized. So we have covered magnetization method and demagnetization method. So we have like hard magnetic materials retain their magnetism. Number 3, magnetic fields are represented by field lines, as we say in the last few slides. Number 4, the pattern of field lines around the magnet can be shown up using iron filings, as we watched in the last video, or plotting compasses here. Number 5, electromagnets have their advantages over permanent magnets, that they can be switched on and off. So this is all for today, and next class we will continue to solve some questions in your textbook. So thanks for listening, and if you have any questions or something not clear, please feel free to contact me and I'm happy to answer your question. Thanks for listening.